Alright, today we're going to do subtract linear expressions. We're going to do pages 404 to 406. I am on 404, starting with problem A. As you can see, as you're looking at your book and following along, that in the first three examples they use the algebra tiles, and if you would like to use that method, you can look at the examples and figure out how to use it. It is related to when we used to use the counters, the positive and negatives, when we made zero pairs, when we did our models for adding and subtracting integers. It's the same concept. You could use the algebra tiles if you wanted to. I'm gonna just do it the regular way. There's actually two ways to think of it. You can think of this subtraction sign here as something that you need to distribute, because you learned the distributive property that I'm not just subtracting 2x, I'm subtracting this whole expression, 2x minus 7. So I'm subtracting the 2x and I'm subtracting a minus 7. So you can think of distributing out that minus or that subtraction sign. The other way is to change subtraction to adding the opposite. So I'll show you both of those methods. First, I'm going to do the distributing idea one, and then on problem B, I'll show you the adding the opposite. And you can choose which method you like and do it that way. So first, if you think of it like distributing, you copy the first expression, 5x minus 9, and then now you're distributing the minus. So you're subtracting that 2x, so it becomes minus 2x. And then you are subtracting a minus 7. But remember, minus minus, or minus a negative, becomes plus plus. So really it should be 5x minus 9 minus 2x plus 7. And now it's just like the previous lesson of adding like terms. You take 5x and the minus 2x, that makes 3x. Minus 9, which is the same as negative 9, we talked about that before. Negative 9 plus 2, the signs are different. You subtract and keep the sign of the one with the greater absolute value, the bigger number we like to say, and you get negative 2. So you can write 3x plus negative 2 or just 3x minus 2. You know that they are the same. Okay, so that's your answer, 3x minus 2. B, so if you want to think of it as that adding the opposite method, this minus, remember we changed subtraction to adding the opposite, but we're not going to just do the opposite of the first one. We have to do the opposite of both because they're both in the parentheses. They're both what are supposed to be subtracted. So if you change this to addition, then you have to change the sign of the other two. So this 2x becomes negative 2x, and this negative 8 becomes a positive 8. And so now what it really says is 6x minus 10 plus negative 2x plus 8. And now it's just like the previous lesson. Find the like terms. 6x and negative 2x. 6x and negative 2x is 4x. And then the two constants are also like terms. Negative 10 and plus 8, positive 8. Signs are different. Subtract, keep the sign of the bigger number. Negative 10 plus 8 is negative 2. So you can write plus a negative 2 or just minus 2. And that's the answer, 4x minus 2. I don't think they're that much different in methods, but if there's one you like better than the other, go ahead and keep doing it that way. I like the distributing method. So I'm going to continue using that one. Let's go to page 405. Here's problem C. So going with that distributive type method, this minus or negative gets distributed to the 5x, and it gets distributed to the negative 4. So I'm going to rewrite my problem. 3x minus 2 minus or negative 5x. We know that's the same thing. And then minus my negative 4. That really becomes plus 4. And now I just find my like terms. Negative 5x and 3x. 3 and negative 5 is negative 2. Signs are different. Subtract. Keep the sign of the bigger number along with the greater absolute value. And then, of course, the constants, negative 2 and positive 4. Same rule. So you get positive 2. And so the answer is negative 2x plus 2. So over here in my answer column, I'll rewrite the answer, negative 2x plus 2. And now D. So same thing. I gotta distribute out that minus or negative sign. So copy minus a negative 2x becomes positive 2x. Minus a positive 2 becomes a negative or minus 2. And now again my like terms, 4x and 2x. 4x plus 2x is 6x. And my like terms, which are constants, negative 4 and negative 2, the signs are the same. So you have to add and keep that sign. So it's negative 6. The answer is 6x minus 6. All right, problem E. So distribute out that minus. 4x minus 3 you keep. And then now negative times the 2x is negative 2x. Negative or minus times the positive 7 is a negative 7. Circle our like terms with the variables. 4x and negative 2x is 2x. And then our constants, negative 3 and negative 7, same sign you add, is negative 10. So the answer is 2x minus 10. And you can write that in your answer column, 2x minus 10. And now for problem F. Same thing, gonna distribute out that minus. So copy 5x minus 4. A negative times 2x becomes negative 2x, or the opposite. Negative of a positive 3, or negative times a positive 3 becomes negative 3. That's distributing out your minus sign. And so the like terms with the variable 5x and negative 2x is 3x. And the like terms that are constants, negative 4 and negative 3, same sign add, negative 7. So the answer for F is 3x minus 7. All right, page 406. If that's going too fast, you know you can pause the video and replay any parts that you need. Okay, number 1. So if you didn't like that distributing one and you like the adding the opposite, I'm going to do that one now for problem 1, so that those of you that like that method can see that more. So keep the 2x plus 4. And now I gotta change and then take the opposite of both of those. I have to change. have to do two changes. Keep, change, and then change, because I have to change whatever the sign of each term that's inside of the parentheses, because that minus is subtracting the whole thing. So now I get plus x and plus a negative 5. And then now my like terms, 2x and x, that's 3x. 4 and negative 5 is negative 1. So it's 3x minus 1. Okay, number 2, keep, change, and then change, change. I have to change this, take the opposite sign of both of those inside. So it becomes plus negative 7x and plus 1. Like terms, 6x and negative 7x is negative 1x. 9 plus 1 is 10, so it's plus 10. So the answer is negative 1x plus 10. All right, here's a word problem, but don't get scared. It really isn't different than all the other ones. You'll find out. Read along. The number of runs scored by the home team at a baseball game is represented by x plus 7. The number of runs scored by the visiting team is represented by 3x minus 7. Write an expression to find out how many more runs the home team scored than the visiting team. So who had more? It tells you right here, the home team. How many more runs the home team scored than the visiting team? So the home team had x plus 7. That's the one that's more. So you know when you're subtracting, you're supposed to take the bigger one and subtract the smaller one. The visitors had less, fewer, and so they're the smaller one. So the visiting team scored 3x minus 7. That's what you need to subtract. And so now it's just a subtraction of linear expressions, just like all the other problems. And so we get x plus 7. I'm going to do my little distributing method again. That becomes minus 3x. And then negative, negative becomes positive, positive, right? Minus, minus becomes plus, plus, which is plus 7. And so then your like terms, x and negative 3x. Remember, there's a 1 here, but you don't have to write it if you don't want to. Just remember there's a 1 there. 1 minus 3 is negative 2. So it's negative 2x. And then 7 plus 7 is 14. And so the answer is negative 2x plus 14. There you go. Number 4. Oh, it says then evaluate the expression. I'm sorry. Good thing I double checked and read my problem like you should. Make sure you read it and to find out if you answered everything it's asking. I forgot the part that says then evaluate the expression if the value of x is 6. So negative 2 times 6 plus 14. Negative 2 times 6 is negative 12 plus 14 is 2. So the home team scored 2 runs more than the visiting team. The home team scored 2 more runs. That's good enough, and since I ran out of space anyway. There's my messy E, you know me. Okay, and my N. All right, number 4. How can you use the additive inverse to help you subtract linear expressions? So that was that second method that I used, which I practiced again here on numbers 1 and number 2, right? And so when you use the additive inverse, the subtracting of linear expressions becomes adding linear expressions. And so you just solve it the same way we did when we learned adding linear expressions. You just add the like terms, combine the like terms. All right, there you go. See you hopefully on Thursday and Friday at Zoom if you have any questions.